One.
Hi, let's look at our notes that are on page 39B in our math notebook. So it looks like the top is cut off of this, but that's okay. We can still know what it says. Basically, there is a car, or the letters of the word deer, D-E-E-R, are on 4 different cards, and you're choosing one, looking at it, putting it back so it's being replaced, and then choosing another one. So the first thing we're going to do is create a tree diagram of all possible options. So when you look here, your first draw would either have a D, an E, or an R. And so your first outcome would be one of those. And then to list the outcomes for the second one, since you're putting the card back, it doesn't matter if you got a D the first time. If you did, you put it back in there. So you could still get, and I know you can't see it, I'm sorry, but you could still get a D, an E, or an R. Or if you drew an E the first time, you put it back in the pile. And so your choices for the next one would be a D, an E, or an R. Same thing with this E. This E, since you put it back, you could get a D, an E, or an R. And if you drew R the first time, you put it back, so you could still get a D, an E, or an R on your second one. So let's organize these outcomes. If we want to know what the probability of drawing a D is, because that's going to be the first outcome you see in your tree. So the probability of drawing a D and then a D, if you look over here, there's 4, 8, 12, there are 16 possibilities, and the one that says DD only happens one time, so 1 out of 16. And then if you're going to make it into a percentage, remember you divide. 1 divide by 16. On the next one, you could do a DE. Well, you have a DE here and a DE here, and then you also have an ED here, an ED here. So altogether, there are 4 of those. 4 out of 16 simplifies to be 1/4. Now, so we've done the first one, we've done the second one. The third one was the same way as the second one. So now we have DR. You can have a DR here. None of these are going to have DRs in them because they'll all have E's in them. So down here, you'll have an RD. So DR, or RD, happens 2 times. 2 out of 16 simplifies to be 1/8. When you look for EE, you know that they could only happen in these 2 middle ones because the first ones are E. So E, so there's 2 there, and there's 2 there. So it happens 4 out of 16 times, simplifies to be 1/4. ER is going to happen here, 1, 2, and then here you'll see RE. So those two, that letter combination happens also 4 times. 1/4 is what it simplifies to. RR is only going to happen 1 time. You know it's going to happen down here because at least one of them has to be R. So there's R, ding, ding, ding. And only this one would also have an R. So that one happens 1 out of 16 times. On the next one, it says that you spin a spinner. See if I can zoom in a little bit without it. Nope. Whatever. You have it in front of you too. You spin a spinner, and it has 24 equal parts. What's the probability you would spin an even number or a multiple of 3? Well, let's list the possible outcomes that give you what you want. So 2 through 24, the even numbers, that would give you what you want. And then also you could count by 3s. 3, 6, 9, 12, 15, 18, 21, 24. However, the even multiples of 3 have already been counted up here, so we scribbled out the even multiples of 3. So now altogether, if you count, there's 12 up there because there's 12 even numbers in 24. And then 13, 14, 15, 16 out of 24. And then I should have simplified that. I apologize that I didn't, but you can simplify a fraction. So make sure you simplify that. Number 3 is talking about mutually exclusive. Mutually exclusive are things that cannot happen at the same time. Like you can't flip one coin one time and get a heads and a tails. On this problem, it's asking if you could, after spinning a spinner with, I think it says 8 different number regions, can you spin a 3 or a 6? Yes, you could spin a 3 or a 6. You could not spin both of them. Like you couldn't spin at one time and get a 3 and a 6, but you could get 3 or a 6. So these would not be mutually exclusive because it could actually happen. You could spin and get a 3 or spin and get a 6. Down here, I actually changed the wording of this problem to make it mutually exclusive. But if a bag contains 6 yellow jerseys numbered 1 to 6 and 4 purple jerseys numbered 1 to 4, and then you randomly pick a jersey that is purple and has a number greater than 5. That would be impossible because the purple jerseys are only 1 to 4. And so you couldn't get a purple jersey and 1 to 5. So those two things would be mutually exclusive. And so again, I did change the wording on this because if it said or, you could get purple or number 1 to 5. But you can't get both of those in the same draw. So thanks for watching these notes.